Honey has been consumed by humans for thousands of years. It appears in ancient texts, religious rituals, medical traditions, and childhood memories. It is associated with purity, nature, and trust. Yet in the modern world, honey has quietly become one of the most questioned food products on the planet. Behind the golden glow in a glass jar, there is suspicion. Adulteration scandals. Labels that promise more than they explain. Words like pure, raw, and natural that sound reassuring but mean very little without context. In grocery stores across North America, consumers stand in front of shelves filled with honey that looks identical, yet varies wildly in price. Some jars cost a few dollars, others cost 5 times more. They all claim to be authentic. They all shine with the same amber clarity. And most people have no idea what separates real honey from something that merely looks like it. Investigations over the last decade have revealed an uncomfortable truth. A significant portion of honey sold globally has been diluted, overheated, filtered beyond recognition, or blended with sugar syrups derived from corn, rice, or beets. These additives are difficult to detect. They mimic honey at a molecular level. They pass through many tests undetected. For the consumer, the deception is invisible. This erosion of trust did not happen overnight. It grew quietly as honey became industrialized, globalized, and commodified. What was once harvested by small-scale beekeepers and sold locally began moving through international supply chains. Honey started crossing borders in bulk containers, changing hands multiple times before ever reaching a jar. Somewhere along the way, distance replaced transparency. At the same time, bees themselves became a subject of fear. Headlines warned of colony collapse disorder, pesticides, parasites, climate stress. Entire ecosystems appeared fragile. If the bees were struggling, how safe could their product really be? And if honey production now relied on massive industrial facilities, what exactly was happening inside them? Most people imagine honey as something that simply appears. Bees collect nectar. Honey happens. A jar is filled. But that comforting mental shortcut hides a complex and highly controlled process that very few ever see. A process where temperature, time, filtration, moisture levels, and microbial activity are constantly managed. A process where a single miscalculation can spoil thousands of pounds of product. There is also the fear of loss. Loss of flavor. Loss of nutrients. Loss of authenticity. Many believe that once honey enters a factory, it stops being real. That machines strip it of enzymes. That heat kills what makes it special. That clarity comes at the cost of life. These concerns are not entirely unfounded, but they are incomplete. Industrial honey processing exists because raw honey, exactly as it comes from the hive, is unstable at scale. It crystallizes unpredictably. It ferments if moisture is too high. It can contain wax particles, pollen clumps, bee fragments, and environmental debris. In small quantities, these imperfections are tolerated. In global distribution, they become risks, yet fear thrives in the absence of understanding. When the process is invisible, imagination fills the gap. Consumers are left to choose between marketing slogans instead of knowledge. They sense that something important is happening behind closed doors, but they are never invited inside. This is where distrust is born, not from what is done, but from what is hidden. Inside a modern honey processing plant, every decision is a negotiation between preservation and precision, between nature and control, between what honey is and what it must become to survive a global supply chain. To understand whether industrial honey processing is a betrayal of nature or its protection, one must follow the honey itself. From the moment it leaves the hive, through every pipe, tank, filter, and sensor, all the way to the crystal-clear jar placed on a kitchen table. Only then does fear give way to clarity. But first, we must go back to where honey truly begins. Honey does not begin in a factory. It does not begin in a jar. It begins in flight. A single honeybee leaves the hive with a specific mission encoded deep within its biology. It is drawn to flowers by ultraviolet patterns invisible to the human eye, guided by scent, memory, and the silent geometry of the sun. Each foraging trip is an act of precision. The bee gathers nectar, a dilute sugar solution produced by plants as a reward for pollination. Inside the bee's honey stomach, enzymes begin transforming nectar immediately. Sucrose starts breaking down into glucose and fructose. The liquid is no longer just plant sugar. It is becoming honey. Back at the hive, this nectar is passed mouth to mouth between worker bees, each transfer adding enzymes and reducing moisture. The bees spread the liquid across wax cells, fanning it with their wings to evaporate excess water. Only when moisture levels drop low enough to prevent fermentation do they seal the cell with wax. Honey is preserved, not by refrigeration or additives, but by chemistry and biology working in harmony. For beekeepers, the hive is both a living organism and a production unit. Modern apiaries can contain thousands of hives, each holding tens of thousands of bees. These hives are often transported across vast distances to follow blooming cycles. Almond orchards in California, clover fields in the Midwest, orange groves in Florida. Each location produces honey with a distinct flavor profile, color, and chemical signature. When the time comes to harvest, beekeepers remove frames heavy with capped honey. These frames are not processed in the field. They are sealed, stacked, and transported to extraction facilities. At this point, the honey has never touched metal. It has not been heated. It exists exactly as the bees left it, thick, opaque, and full of microscopic life. Extraction begins with uncapping. Thin layers of wax are sliced away to expose the honey-filled cells. The frames are placed into centrifugal extractors, spinning at controlled speeds. Honey is flung outward by force, collecting along stainless steel walls and draining downward. Gravity does the rest. The raw honey that flows out is far from perfect. It carries wax particles, air bubbles, pollen, and traces of the hive environment. Its moisture content varies. Its viscosity depends on temperature and floral source. This variability is beautiful, but it is also unstable. From the extraction facility, honey is transferred into food-grade drums or intermediate bulk containers. These containers can weigh hundreds of pounds. They are sealed, labeled, and shipped to processing plants. This is the moment when honey leaves the beekeeper's direct control and enters the industrial system. For many consumers, this handoff is where anxiety begins. The distance between hive and jar suddenly feels vast. But curiosity reveals something else. It reveals that without this transition, most honey would never reach consumers at all. Processing plants exist not to erase honey's origin, but to manage its variability. They must handle honey from different regions, seasons, and floral sources, each with unique properties. Some honey crystallizes quickly, some remains liquid for months, some contains higher moisture levels that could ferment if left untreated. The plant's job is to stabilize honey without turning it into something else. This is not a simple task. It requires understanding honey at a molecular level while respecting its biological roots. Before any processing begins, samples are taken, color is measured, moisture content is analyzed. Electrical conductivity provides clues about floral origin. Pollen analysis can confirm geographic authenticity. These tests are not optional. They are the foundation of trust in the system. Only after honey is understood can it move forward. Only after origin is respected can processing begin. Curiosity replaces fear when the path becomes visible, and that path leads directly into science. Inside a modern honey processing plant, nothing is accidental. Every valve, sensor, and temperature reading exists for a reason. Honey may be natural, but controlling it at scale requires science. Raw honey enters the facility as a thick, semi-solid substance. At room temperature, it moves slowly, resisting pumps and pipes. To make honey workable, it must be gently warmed. This is one of the most misunderstood steps in the entire process. Heating honey does not automatically destroy it. Temperature and time are what matter. In processing plants, honey is warmed just enough to reduce viscosity, often between 95 and 120 degrees Fahrenheit. This temperature mimics the warmth of a beehive. It allows honey to flow without caramelizing sugars or degrading enzymes. As honey moves through jacketed pipes, sensors constantly monitor temperature. Automated systems adjust heat in real time. If temperatures rise too quickly, alarms trigger. Human operators intervene. Control is continuous, not passive. Once fluid, honey passes through filtration systems. These are designed to remove physical impurities, not nutrients. Wax fragments, bee parts, and debris are captured by fine mesh filters. The goal is clarity without sterilization. Honey is not pasteurized like milk. It is stabilized. Moisture content is critical. Honey with moisture above approximately 18% is vulnerable to fermentation. Yeasts naturally present in honey can activate, producing gas and off flavors. To prevent this, processors may use controlled dehydration systems. These remove minimal amounts of water under vacuum conditions, preserving volatile compounds. Every batch is tested again. Moisture, pH, density. These measurements are not about standardization for appearance alone. They are about safety and shelf stability. Without them, honey could spoil on a consumer's shelf months after purchase. Blending is another misunderstood step. Blending does not necessarily mean dilution or adulteration. It means consistency. Honey from different drums is combined to achieve stable flavor, color, and crystallization behavior. Without blending, each jar would behave differently. Some would crystallize rapidly, others would remain liquid. Consumers would perceive this as a defect. Throughout the plant, data flows alongside honey. Digital records track each batch back to its origin. Traceability systems ensure accountability. If a problem is detected, affected product can be isolated within minutes. Human judgment remains essential. Experienced technicians monitor viscosity by sight and sound. They listen to pumps. They observe flow patterns. Machines provide data, but humans interpret meaning. This balance between automation and intuition defines modern honey processing. Science does not replace nature. It protects it from chaos at scale. Control is not about domination. It is about preservation. Yet even with science, risk remains. And that risk becomes visible when things go wrong. Honey is stable, but it is not invincible. Inside a processing plant, small deviations can have massive consequences. One of the greatest risks is fermentation. A single batch with elevated moisture can contaminate an entire tank if undetected. Pressure builds, flavor changes, containers swell, the product becomes unsellable. Preventing this requires relentless monitoring and immediate response. Another risk is overheating. If honey is exposed to excessive heat, hydroxymethylfurfuryl levels increase. This compound is used as an indicator of heat damage and age. High levels can disqualify honey from certain markets. Sensors exist to prevent this, but they rely on calibration and oversight. Contamination is a constant threat. Honey passes through shared equipment. Sanitation protocols are strict. Stainless steel surfaces are cleaned with food-safe agents. Downtime is scheduled for deep cleaning. Any lapse can introduce foreign substances. There is also economic risk. Honey is valuable. A single storage tank can hold tens of thousands of dollars worth of product. Equipment failure, power outages, or human error can result in catastrophic losses. Emergency protocols exist for these moments. Backup generators engage within seconds. Valves automatically close to isolate compromised sections. Operators are trained to respond under pressure. The plant is quiet, but readiness is constant. Even crystallization poses risk. While natural, uncontrolled crystallization can clog pipes and damage equipment. Plants manage this by controlling cooling rates and agitation. Precision prevents chaos. Behind every jar of honey is a silent struggle against entropy, against the natural tendencies of a living substance. Tension is not dramatic. It is quiet, technical, and relentless. This is where fascination begins, because despite the risks, the system works. Day after day, jar after jar, through precision. As honey approaches its final form, the process becomes almost hypnotic. Flow meters measure exact volumes. Automated fillers dispense honey into jars with millimeter accuracy. Lids are sealed under controlled torque. Clarity is achieved not by stripping honey of its identity, but by aligning its structure. Microfiltration removes particles large enough to scatter light, revealing the honey's natural translucence. Labels are applied. Lot codes are printed. Each jar becomes a data point in a vast system of accountability. Packaging materials are chosen to protect honey from light and air. Logistics systems calculate optimal routes to minimize temperature fluctuations during transport. What appears simple is anything but. Every movement is synchronized. Every delay has consequences. The plant operates like a living organism, responding to internal and external signals. This is industrial beauty, not loud, not flashy, but precise, predictable, trustworthy. The honey that leaves the plant is not less natural. It is more resilient, more reliable. It carries the work of bees, humans, and machines together. And finally, it arrives where the story ends, or perhaps where it truly begins. A jar of honey sits on a shelf. It catches the light. It waits. The consumer sees a product, not a process. They twist the lid. They taste sweetness. They rarely consider the journey behind it. Yet inside that jar is a record of choices. Ethical sourcing, environmental impact, scientific restraint, industrial discipline. Honey is no longer just a gift from bees. It is a collaboration, one that carries responsibility to protect pollinators, to respect ecosystems, to maintain honesty in labeling. When trust is restored, fear fades. Transparency replaces suspicion. Understanding replaces assumption. The next time honey is poured into tea or drizzled on bread, it is no longer anonymous. It is known. And in knowing, the consumer becomes part of the system. A final link in a chain that began with a bee in flight.